Hello everyone. Today I'd like to briefly introduce about the MAR 3039 and especially this course will be shared by the Simon and the Yongchang, and I'm planning to cover the shear and torsion related topics. So as you could see here, in total we have almost 8 to 10 topics, but from the stage 1 module, if I'm not mistaken, we've learned about all those topics. So simple beam theory we started, and then we introduced about the Euler-Bernoulli beams before. And if you don't remember, I have added some additional materials in the pre-study material, so please have a look. And from that we learned that the Timoshenko beam theory, the reason is that there was the limitation of the simple beam theory. The reason is we need to consider the shear phenomenon, and we have briefly learned about the elastic moduli, and for that we need to understand the effect of the shear stress in beams and shear stresses in different cross sections. All those things have been covered in the MAR 109 stage 1 module. So please try to remind your memories. Of course, you might not be able to remember everything. That is reason why you'd better to click the pre-study material. I have put some additional tutorials as well, so it might be better for you to understand it. So from that knowledge and the previous outcomes, we're gonna start about the shear stress in asymmetrical beams and shear center concept from topic 5. So I would say that this might be our first topic, and followed by the torsion related topics. So as you could see here, we'd better to understand the flow. So previously we learned from the beam methods, and as you could see here, the ship structure could also be considered as the simple beam. You know what I'm saying? So from here we derived all the formulations related to the simple beam theory, because the simple beam theory, the shape of the simple torsion theory is also similar as simple beam theory. That is reason why I would recommend you to study on topic 0 to 4. This is the right time. And limitation, once we apply the simple bending or the pure bending, or like that, once we apply the shear bending, the pure bending moment like this, even we cut the section at the center, the plane will remain the 90 degree with the neutral plane 90 90 90. But in actual conditions, once we consider the individual fiber here, individual fiber tends to be slipped each other like here. This is like shear effect, so raised by the Timoshenko. So once we apply the actual shear here, then the behavior will be like the top one, and the next one, it will be changed like that. You know what I'm saying, right? So we have focused on the limitation of the simple beam theory. So from that we need to understand the material behavior, normal stress and strain methods. And of course, if we consider the shear, this vertical axis will be converted to the shear stress and shear strain. And of course, we have learned this slope or the stiffness is the stress is E epsilon. This E is elastic modulus. In the case of shear case, here that should be G is shear modulus. So we need to understand the relationship between E and G. Of course, we need to know the Poisson's ratio as well. That could be found in topic 2. And the effect of shear stresses in beam and the shear stress in different cross sections, that has been covered in MAR 2021. Do you remember? We started from the global and the local. This is related to the section, but at that time, in the case of global, we started from the beam meta, distributed load, or the concentrated load is applied, so that we could think about weight distribution. At the same time, we have the buoyancy forces, so weight minus buoyancy, that was considered as the distributed load. So once we define the distributed load, bring it to here, then integrate it along the length of the beam or the length of the ship, then there will be the shear force. So shear force diagram, we could be obtain it, and then integrate it again. That was bending moment diagram. So now you could remember the procedure, how to solve the global strength issues. So after that, we discussed about the local methods, about the beam section. At that time, our assumption was our beam section is like symmetrical or symmetrical beam. But here in topic 5, we will discuss about the symmetrical, is like this kind of symmetrical shape will be introduced, because this is the connection between the shear and the torsion. So in this case, it will tend to be twisted or this way. Okay, and then we need to introduce shear center concept, like shear center. In general, we put E. This is the length from here. So this is the overall for these shear methods. And then this is topic 5 is our first lecture topic, and this is the truly important for us, the connection bridging between this one and torsion methods. And then we will move on to the torsion, and MAR 1009, if I'm not mistaken, topic 12 or 13, we've learned about the basics of the torsion. We apply the torsional moment, and we drive the basic functions, and at that time we have not discussed about the details, but here in MAR 3039 stage 3 module, we will discuss about the closed section first, subjected to the torsion, and it's like circular closed, and topic 6. Then we move on to the open section. For example, like we can make a small opening here, right? So in this case, how will be the shear flow and shear related behavior subjected to the torsion? As you can see here, that once we apply the torsion, it will generate the shear related stresses. So actually shear and the torsion is closely related. At the same time, as you can see here, this is our ship structures. Once we apply the vertical bending moment, like sagging or the hogging, at the midship section, bring it, then at the deck side it will be compressed, and at the same time the outer bottom will be stretched, the tensioned. So it means that the bending stress will be related to the actual loading, actual tension or the actual compression. In the case of torsion, it will generate the shear. So this is important for us. So that was a topic 7 here, open section. At the same time, right after the topic 7, we will discuss about the multi-cell sections. So why this multi-cell section is important is here. As you can see here, this is a typical example of the the oil tanker, the midship sections. So as you could see here, so this is the deck, and this is ballast tank. The steepness should be there, and center line. So this is more than 2, or sometimes in the case of VLCC or the ULCC, we can see like this. This is single hull type. Of course, after we adopt the common structural rule CSR, we need to install double hull system, so it's like that. So in this case, this is the 3 cells system, and this is 2 cell system. So multi-cell section, that is related to our ship structures. So we will have a look once we apply the torsion here, and at the section we will see how the flow of the shear will be like that, and then the effect of the shear stress, and how we're gonna design our the sections, about the thickness, safety assessment, something like that. So from here you can understand, previously we learned about the bending and axial compression, axial tension, and buckling methods. Of course, in here we briefly learned about the simple beam theory and limitation, briefly discussed about the shear methods, but here we will more focused on the shear center concept and twisting, asymmetric beam, and torsion in the closed section, open section, and multi section. So that will be covered by me in this module MAR 3039, and the other modules like FEM and the fracture mechanics and the fatigue will be covered by the Simon and the Yongchang. So that's all for today, and thanks very much.